Hi guys, welcome to the next lecture. In this lecture, we will try to graph some important functions. We will try to see what the shape of any particular function that we take up turns out to be on the graph. So let's start with the first function, which I'm taking as y equals to x. That means I am basically taking fx equals to x. Now, what will the shape of this graph look like? It is clearly a linear case. The power, if you will see, for the variable x is 1. So it's a linear case. Now, the function y is equal to f of x is actually equal to x itself. That means when x input, I take it up as -2, the output y turns out to be -2. When I take up x input as -1, the output turns out to be -1. When I take it up input as 0, output itself is 0. When I take input as 1, output is 1. When I take input as 2, output is 2. Now, graphically, if you will try to plot it up, what will it look like? So, x0, y0, this is your x-axis and this is your y-axis. So the vertical line is giving you the values for y and the horizontal line is giving you the values for x. This point is for 0 where x and y both are 0. This point, this is 1. So x is 1 and y is 1. That point could be located here. And the point is 1, 1. That is x also 1, y also 1. Then x is 2, y is 2 will be shown out here. 2, 2, -1, x is -1, see? And y is -1 comes out here, -1, -1. Similarly, x is -2 and y is -2 comes out here. -2, -2. Now, if you can just join these points, that will give you the graph of this function. And you can extend it. Just extend it. There is no stoppage on what input you can take. So you are taking an R2R function here. What you would realize is that all the points that you will have, the function is such that you will be getting the points on this line. They will be all x equal to y, that is x comma x or y comma y. Those are the points that you will be plotting in here, and that will be the graph for this function. The next important graph to be discussed today is the graph of x squared. So when y is equal to x squared, or in other words, f of x is equal to x squared, what is the shape that the graph of this function would take on the Cartesian plane? Clearly, this is not a linear case because you have the degree is 2 of the variable that we have in our function. It is x squared. So let's think in terms of, first of all, values and then in terms of shape. The value of my input, in case it is -2, what turns out as my output? It's going to be 4. -2 square. -1 square will be the output when the input is -1, which is 1. 0 square is the output. When input is 0, you get 0 as an output. That means 1 is the input, output is 1. 2 is the input, output is 4. If you see, you are getting the same values for the negative and positive of numbers here, which is because the power of x is 2. So when you square any number, you get a positive entry, right? You get a positive number as a result. Clearly, the domain of this function is R, but the range of this function is R plus. Please remember that. Now, let us plot these points on the Cartesian plane. So when x is 0, y is 0 comes in here. When x is -2, y is 4. That means this is the point we're talking about. This point is -2, 4. When x is 2, again, the value of the function is 4. So this is the point that we are talking about on the Cartesian plane, 2, 4. For -1 input, the output is 1. For 1 input, the output again is 1. So it's going to be something of this sort. Now let's try joining these points and we will realize what the shape turns out to be. So joining these points, you would realize the shape turns out to be exactly a convex parabola. As you can see out here, it's a convex shape. It's a strictly convex shape. I haven't yet spoken about that, but we will be doing that later. It's a strictly convex shape, and as you can notice, it's a parabola. And that's what x squared as a function is graphically. Let's now take up another interesting graph. Let's take the function fx equals to x cubed. What would be the shape of x cubed on the Cartesian plane? Let's see that. In case your input x is -2, y would be this cube of -2, and cube of a negative number is a negative number. So what you will get is -8, right? -1 is your input. So output is -1 to the power 3. -1 into -1 into -1, 3 times will give you -1 again. If your input is 0, 0 cube will give you 0 itself. If the input is positive, what comes out of the cube is positive. So 1 cube is 1, 2 cube is 8. Well, so if we try to plot this on the graph, what will it look like? So let me start with 0. If x is 0, y is 0, so this is the point, the center, right? If x is 1, y is 1, so this point is 1, 1. If x is 2, we've seen that y turns out to be 8. So 2, 8 is another point, which is on the graph. Similarly, when x is -1, what we are getting is -1. So -1 out here. When x is -2, what we are getting is -8 as our output. So hence these are the points which would lie on this graph of x cubed. And hence what we will do, we will join up these points in order to see what the graph actually looks like. Joining through these points, you would see the graph is looking something of this sort. There's also another way of thinking about this graph. I would like to give you this food for thought here. Look at the slope of this function. The slope of this function is 3x squared. 3x squared is always greater than or equal to 0. Right? So that means it's an increasing function. Throughout this domain, it's an increasing function. So the values are increasing, and then going up like this. Another food for thought I would like to give you here is to think in terms of curvature. When we think in terms of curvature, we actually have to look at the double derivative or slope of the slope function. Don't worry, I'll be talking about all these things in details as well as we move on in these lecture series. But for now, please try to understand there is a curvature attached to any function, any differentiable function. It's easy for us to see the curvature. We look at the double derivative, which throws light on what kind of curvature it would be. So what we see here is that the double derivative will be 6x. Now 6x is such a value that it could be positive also, it could be negative also, depending on the value of x. So 6x would be greater than 0 when x is greater than 0. 6x would be less than 0 when x is less than 0, which means that when your x's are positive, the curvature, There's a name to this kind of a curvature where your double derivative is positive. When your double derivative is positive, we call that the curvature is convex in nature. And when the double derivative is negative, we have another name for it. We call the curvature concave. So yes, this function is an increasing function, which is concave when x is less than 0 and convex when x is more than 0. And hence you have this kind of a curve happening here. Okay. Now let's take up another example. Y equals to square root of x. If y is equal to square root of x, then first thing that you should think in this kind of a function when you're discussing this kind of a function, what is the domain for this function? The domain for this function is definitely r plus, because we are taking the square root. So x cannot be negative. X has to be greater than or equal to 0. So when I am trying to look at the points, various inputs and output coming out of it, I am taking all positive entries. When x is 0, y turns out to be 0 for sure. When x is 1, y square root of 1 turns out to be 1. When x is 4, y turns out to be 2. When x is 9, y turns out to be 3. So if we may note what this function will look like here. So 0, it's 0. For 1, it's 1. For 4, when the input is 4, the value is of the function is 2. When the input is 9, the value of the function is 3. So seems like this function moves a little like this. Joining these points 0, 0, 1, 1, 4, 2, 9, 3, and so on and so forth. Of course, it will go up, up, up like this here. So this is the kind of graph which will get generated. Another important graph in mathematics and allied subjects is the graph of reciprocal, that is 1 upon x. One thing that you need to understand when you are taking the function fx equals to 1 upon x is that I cannot take x as 0, because at 0, this number is not defined, right? So our domain for this function is all real numbers are good except for 0. See, I'm not even looking at the input 0. That's because when x is tending towards 0, when x is moving towards 0, fx would be moving towards infinity. Okay? Now, when x is minus 2, what's going to happen? We do get a valid entry. I can take negative numbers also here. I'm going to get minus 1 by 2 or 1 upon minus 2. That is same as minus 1 by 2 by the properties of number. Minus 1, the output I get minus 1. Input is 1, output again is 1. Input 2, output half. So if we may look at the Cartesian plane here, I'm going to get 1, 1. I'm going to get minus 1, that's here. I'm going to get 2 half. So it's here. I'm going to get minus 2, minus half. So that's somewhere minus 2, minus half. So that's here, right? And you would notice what's going to happen is for 3, you'll have 1 by 3, 1 by 4, 1 by 5. It's getting smaller, it's smaller. Similarly, here also minus 1 by 3, minus 1 by 4, smaller and smaller. And in case you take fractions between 0 and 1, what's going to happen? So let me just add on some values here. So if I take half, I'm going to get 2. If I take minus half, I'm going to get minus 2. So that's pretty interesting here. So if I take half, I'm going to get 2. So we are getting higher values this way. And here also, if I take my input is, see, half, I'm going to get minus 2 here. So that's here. Then here, it's going to move something of this sort. And can you see something here? A shape which is called rectangular hyperbola. That's the shape which is getting generated. Okay. But remember, it's on this quadrant and this quadrant, because if your input is negative, the output turns out to be negative. If your input is positive, the output turns out to be positive. So plus quadrant and minus quadrant is what our result as a graph is. So if you join up these points, you would see this kind of a shape will get generated from the vertically. If you will see, it will never touch the axis, but it will keep on moving, because as x is going to infinity, y is turning out to be 0. As x is 0, then y is turning into infinity. So you can see that a rectangular hyperbola in the first quadrant and the third quadrant will get generated. The next function, which is a function I'm going to take up in detail as well. It's a very important function, the modulus function. Y equals to f of x, which is equal to modulus, or the absolute value function. Now, what is the absolute value function? Absolute value function says that you just look at the absolute value. Do not consider the sign behind it. So hence, absolute value or modulus function is defined as whatever is inside these two bars stand for modulus or absolute value. These two bars, whatever x is inside, if that x is positive or 0, you just take the value as x. If it's a negative number, you take the value as minus x so that the value becomes positive. So we are interested in the absolute value. Absolute value in that sense means that you're not bothered about the sign. We're just talking about the value. In another way, it is basically the distance from origin. But for now, just try to understand that absolute value, you're not bothered about the sign. You want just the value. So for example, if you take minus 2, the absolute value of minus 2 is negative, right? So as I mentioned here, the function, we're supposed to take minus of, if x is negative, then take minus of that value. So minus of minus 2 will give you value 2. So the absolute value is just the positive quantity that matters. Okay, negative, positive number, we are not bothered about the sign. We're just bothered about the value. Similarly, minus 1 would be minus of minus 1, that is 1. 0 will give you 0. Absolute value of 1 is just 1. Absolute value of 2 is just 2. So when you will graph it, can you see you're getting symmetricity? You're getting same values. So this graph is symmetric around 0. So the points are 0, 0. You can see 1, 1, 2, 2. Similarly, 3, 3, 4, 4, so on and so forth. And for minus, it will be, so instead of going down minus 1, we are interested in just the value. So absolute value of minus 1 is 1. The distance from the center, 0, is actually 1 unit. So we're just interested in that distance. That's what is absolute value function. So with minus 2, the absolute value of minus 2 is 2. The absolute value of minus 3 is 3. Absolute value of minus 4 is 4. So this, when you will join these points, so you'll get this shape, x equal to y sort of a shape. But this time, for negative numbers, also you have a positive y of the same quantity. So that's how it will keep on moving. That's what is an absolute value function graph. This is the graph of mod x. It's a V shape. You can see that the shape is actually strictly convex in nature, that the shape, but it's not a differentiable function because you are getting a kink here. For all those who do not understand that language for now, ignore it. We will talk about it later.